Before going to start, if you are new to my channel, please subscribe my channel. Okay, let us start. As we know, one of the famous experiment to determine the size of the nucleus, that was explained by Rutherford. We call it as a Rutherford alpha scattering. Okay, so Rutherford concluded that atom of any element consists of central core, that is called nucleus. So the electrons which are revolving around the nucleus, and nucleus consists of protons and neutrons, two particles, that are proton and neutron. Proton is positively charged, whereas neutron is neutral, and electron which revolves around nucleus is negatively charged. And mass of the proton and neutron are quite similar, 1.6 into 10 to the power minus 7 kg. And charge, only proton has the charge, that is 1.6 into 10 to the power minus 19 coulomb. For electron also quite same. Then electron mass is given by 9.1 into 10 to the power minus 31 kg. Okay. And proton and neutrons together exist in nucleus, which we call them as nucleons. Okay. And atomic number, the sum of proton and neutron, that is called atomic number. We usually number of protons inside the nucleus, we call it as atomic number, that is denoted by Z. Sum of the proton and neutrons, we call it as mass number, capital A. Okay, so Z is what? Atomic number. A is mass number. So let us take example like carbon. It consists of 6 protons and 6 neutrons. Then atomic number is what? Number of protons. Mass number is what? Number of protons and neutrons. So if you want to calculate number of neutrons, 12 minus 6, that is 6 neutrons are there for carbon. Some general properties of nucleus we have to discuss here. First one, nuclear size. It has been proved experimentally that radius of nucleus is given by r is equal to r naught into a to the power 1 divided by 3. So radius, capital R is what here? Radius of the nucleus. R naught linear constant, and it is equal to around 1.4 for me. For me is what? 10 to the power minus 15 meter. So mass number of the nucleus is what? Capital A. So radius of nucleus is of the order of what? 1 Fermi, that is 10 to the power minus 15 meter, size of the nucleus. Nuclear charge. As we know, protons and neutrons are there inside the nucleus. Neutron is neutral, it doesn't have charge, so only proton has the charge. Then charge of the neutron is given by what? Charge of protons, that is positive ZE. Proton, number of protons is what? Atomic number. So charge of helium, if you want to know, that is 2 units, because it consists of 2 protons. Nuclear mass. Mass of the nucleus is what? Total number of protons and neutrons. So it has been proved that 1 atomic unit is equal to 1.6 into 10 to the power minus 27 kg. So if you take again example of carbon, it consists of 12, mass number is 12. So 12 atomic unit. Okay, 1 atomic unit is how much? 1.66 into 10 to the power minus 27 kg. So then you can calculate the net mass of the nucleus if you know the protons and number of neutrons. Then nuclear density. Density is what? Mass by volume. So nuclear density is what? Mass of the nucleus, okay, to the volume of the nucleus. Mass of the nucleus, we can write it as m into capital A. Volume, it is a spherical in shape, nucleus. So 4 divided by 3 pi r naught cube divided by A. So here we will have, this is the general equation for density of nucleus. So you can see density of nucleus, just you can put the mass of the proton and then radius r naught value, 4 pi is what, 3.142. Then what is the density of nucleus? That is 1.8 into 10 to the power 17 kg per meter cube. So density of nucleus is very large, that is of the order of 10 to the power 17, and it is independent of mass number A. You can see here it is independent of mass number. Then nuclear density is not same throughout the nucleus. It is maximum at center and decreases gradually from the center. Nuclear radius is distance from the center of the nucleus, at which density of the nuclear matter decreases half of its maximum value at the center. And value of nuclear density is far greater than atomic density. Obviously, nuclear density is going to be greater. Then nuclear spin. So as we know, the spin of the nucleons is given by half value, that is intrinsic angular momentum, half h cross. As we know, electron is going to revolve around the nucleus as well as it revolves around its own axis. So in addition to their spin, they have they move along the orbits like electron in an atom. Nucleons also has the same property. So nucleons have orbital angular momentum also, and the total sum of intrinsic angular momentum plus orbital angular momentum, we call it as nucleus or nuclear spin. It is to be noted that along preferred direction, the spin angular momentum is taken to be plus half h cross and anti-parallel, that is minus half h cross. Thus, if mass number is odd, total spin angular momentum is going to be odd half integral. If it is even half integral. So next important property, that is nuclear forces. Some force is holding nucleons together inside the nucleus. So that is called nuclear force. There are three types of attractive forces. One is between proton and proton, between neutron and neutron, between proton and neutron. So general nature of nuclear forces here. First one, they are short range forces, because nuclear size is what, 10 to the power minus 15, 1 for me. So this distance is very small. Okay, after that nuclear force will become repulsive. So that's why it exists within 10 to the power minus 15 meter. So that's why it is short range. They are strongest known forces in nature, and they are charge independent, because nuclear forces make no distinction between nucleons. They are non-electric because positively charged protons and neutrons have neutral charge. So they are attractive. Net effect of nuclear force is what, attractive. If it is not attractive, then nucleons will not be inside the nucleus. Then next, they are non-gravitational. So gravitational force is what, long range force. This nuclear force is very short range. So they are too weak to keep the nucleons inside the nucleus. That's why they are non-gravitational. They are spin dependent. This is very important. Many questions have been asked on this. The nuclear force depends upon the mutual orientation of the spin of the nucleon. For example, neutron, proton, which are kept inside the nucleus, forming a deuteron only if their spins are parallel to each other. So they will depend on spin. Next, they have saturated properties. Interact in the nucleus, any one nucleus interacts with only a limited number of other nucleons nearest to it. So not all the nucleons inside the nucleus. Okay, this is referred to as a saturation nuclear forces. So these properties are very important. Then mass defect and binding energy also very important. Mass defect, as the name indicates, as we know, proton and neutrons as we call mass number, and if we take the masses of individual nucleons, if we add that total mass of the nucleus and masses of the constituent particles are not same. There is a difference. This difference in mass is known as mass defect. So difference between actual mass of the nucleus and sum of the masses of constituent nucleons is called defect. So it is given by delta M, mass defect, ZMP plus A minus ZMN, as we have the general formula for mass of the nucleus. But M is what? Total or actual masses of the nucleus. If we take the difference between them, we will have the delta M. So some force, some energy is holding together in nucleons in the nucleus, that is called binding energy. So it is obtained by conversion of mass defect into energy. So there is a relation between binding energy and mass defect. So C is what? Speed of light. Binding energy also used to break the nucleus into its constituent particles. Okay, let us understand the binding energy of the nucleons. The example, let us take alpha particle, which consists of 2 proton and 2 neutrons. So mass of 2 proton, just write down here, mass of 2 neutrons. Okay, then total mass, you have to add these two, and then alpha particle, that is equal to what? Nucleus of helium. So what is the mass of that? 4. You can see there is a difference in the masses, total mass and individual sum of the nucleons. So mass defect will be what? 0.0293 into atomic mass unit 931. If you multiply, you will get the binding energy. So binding energy per nucleon is what? Number of nucleons, how many are there? 2 protons plus 2 neutrons. 4. 27 by 4. So 6.82 is the binding energy per nucleon. So what is binding energy per nucleon? It is given by the, we also call it as specific binding energy or average binding energy. That is total ratio of total binding energy to the total number of nucleons. So there is a relation or graph between mass number and binding energy per nucleon. When we plot a graph of average binding energy versus mass number for the different elements in the periodic table, so you can see how the variation is there for different mass numbers. Okay, so from this graph we can come across the important observations here. The binding energy curve rises rapidly in the beginning and then gradually attains maximum value at about 8.8 mega electron volt. So initially, if we take the elements having the mass number below 20, they have less binding energy. After that, they gradually increases and attains maximum value at 8.8 around for mass number 56, that is for iron. 56 to 80, they are more stable elements in the periodic table. This is the reason of maximum stability. So here fusion will take place and fission process after the 80 mass number. After that, it is gradually decreases up to 240 mass number, that is for uranium 238. We can take isotopes of uranium. It reaches to 7.6 mega electron volt. Okay, so for lighter nuclei, binding energy curve gradually increases. So it means it is very low and it is not stable. Atoms having mass number between 2 to 20, they are sharply defined peaks having even multiple of mass number 4. Helium, carbon, beryllium, carbon, oxygen, neon. There is a difference of 4 mass number. After the mass number 20, there is a gradual increase in binding energy up to 8.8, that is for iron. Then binding energy per nucleon, nucleates having number ranging from 40 to 120 are close to maximum value. After that, value decreases and falls to 7.6 mega electron volt, that is for mass number 238, that is uranium. Okay, so just you can understand the average binding energy versus mass number with this curve. So this is all about basic properties of nucleus. After understanding these properties, you can just solve few problems related to that. First one, let us take the order of magnitude of binding energy per nucleon in a nucleus is. So first what we have to write here, according to uncertainty principle, we cannot measure position and momentum simultaneously. So delta x delta p is equal to what? H cross. So delta p x is minimum, which is equal to h divided by delta x. Nothing but delta x is what? Radius of the nucleus. That is here radius 2 times r. Then delta p, if you want to write in terms of kinetic energy, delta p divided by 2m is equal to h cross divided by 8m square r square. For stable nucleus, we can say binding energy is of the order of maximum kinetic energy. So therefore binding energy, nothing but whatever the expression we have written, h cross square divided by 8m p, that is mass of proton, radius r square. Just substitute the value of Planck's constant, mass of proton, and then r value. Then you will get the binding energy per nucleon for a nucleus, that is 10 mega electron volt. So the next question, nuclear forces are spin dependent, have non-central part, spin dependent and have a non-central part, spin independent, have no non-central part, spin dependent and have a non-central part. Obviously, as we read the properties, spin dependent and have a non-central part. The volume of a nucleus in an atom is proportional to. So property size of the nucleus is what? R is equal to R naught into a to the power 1 divided by 3. So if we take volume here, volume of nucleus is what? 4 divided by 3 pi r cube. So volume is directly proportional to what? mass number. So the option A is correct here. Which refers to nuclear forces, which of the following statement is not true? Short range, charge independent, velocity dependent, spin dependent. Obviously short range, charge independent, velocity dependent, spin independent is not true because they are spin dependent. So few problems are always asked on the radius or size of the nucleus. First formula you should understand: R is directly proportional to a to the power 1 divided by 3. R is equal to R naught. R naught value is how much here? How you can calculate R naught value? If the mass number has been given, then you can just calculate R naught value here 1.2 for me. It is always lies between 1.2 to 1.4. Okay. Then for example, if you take a copper, its mass number is what? 64. R naught 1.2. Then what is the radius of copper here? 4.8 for me. And so many of the problems have been asked for the ratios of the radius of two elements. Let us take R1 and R2 are the radius of a given elements, two elements. Their mass number, you have to take the ratio. Then R1 by R2 is what? A1 by A2 to the power 1 divided by 3. So let us take ratio of radiuses of lead and oxygen. So mass number of lead and oxygen you must know. After substituting, R0 is what constant, 3 into 10 to the power minus 15. Then you can calculate the radius of lead. So another example, here radius of ratios of gold and silver you have to calculate. Mass number you have to substitute. Then you can calculate the ratio of this. Next example. For example, mass number of A2, that is 120, that is for xenon. Okay. And oxygen they have given here 16. R2 ratios you have to take R2 by R1, A2 by A1. 128 by 16, how much? 8 you will get. Cube root of 8 is what? 2. So R2 is equal to 2 times R1. R2 is equal to 2 into R1 is what? 3 into 10 to the power minus 15 meter. Then you can calculate the radius of another given element, that is xenon. So like that you have to solve the problems related to properties of the nucleus. I hope this explanation is helpful for you to understand the concept of nuclear physics. If you found this video helpful, please like, share and subscribe my channel. Thank you for watching.